Nobody installed smoke detector because they prevent fires. They install them because early detection prevents small problem to become catastrophic losses.
Lightning is by far the biggest issue that we've had over the last 20 years. The severity is increasing, the frequency is increasing.
A crack that is 30 centimeter long would cost you $30,000 to $50,000 to fix, compared to a blade snapping, which cost you between, well, let's say, $300,000 to $1,000,000,
And the rest.
and the rest.
Hi everyone, I'm Sylvia Leyva Martinez and this is Interchange Recharged. Today in the podcast we're going to be talking about a technology that we have not discussed in a while here, that is wind. Wind had a record-breaking year in 2025 with more than 170 gigawatts of capacity installed and is on track to reach its second terawatt globally by 2030. So today we're going to talk to two different people that are sitting at opposite sides of the same issue. As turbines get larger, bigger, and more powerful, and also more expensive, who's making sure of this industry's ability to manage that risk as it keeps scaling up? I'm joined today by Alexis Grenon, CEO of Onyx Insight, which turns condition data from inside the turbine into decisions that operators can act on. And on the other side is Olly Litterick, head of renewables at Tokio Marine GX, one of the insurers that is pricing that risk every day. We'll get into the race to scale, why wind is oddly related to the smoke detector at your home, and what real ownership of turbine data could unlock next. So let's dive in. Alexi, Olly, welcome to Interchange Recharged. I'm so excited to have you on the show.
Thank you very much.
Thank you.
In one sentence, from where you each sit, what is the single biggest change in the wind industry that has happened over the past, let's say, 2-3 years?
I think certainly for what we've experienced over the last few years, really, the most obvious one is scale. Quite simply, the scale of wind turbines, and certainly the pace in which they have scaled up has been pretty significant. And the other sort of major change, if I can give two, is a big shift towards a much broader and diverse group of OEMs. There's no longer the reliance on the major European manufacturers. There are now manufacturers further east that are providing alternative solutions. So that, from my side, is probably the two biggest shifts that we've seen over the last few years.
Thanks, Oli. And from my side, we've seen in the last 2 years some amount of uncertainty, and we've seen a shift from speed and development to an area of operational efficiency.
Okay.
Every dollar counts.
Perfect. When you say like shift from speed of development, is it the time that it takes for a project to like be planned and all the way until it gets built, or
Well, we've seen in the past massive amount of dollars funneled into developing new wind farms, new assets, and speed really matters. And we're seeing in those days with some evolution of the macroeconomics and the political environment that is somehow impacting this industry, we've seen a focus on operational efficiency. ROI really matters and start to matter more than speed and amount of development.
We've certainly seen improvements in speed as to the way, the speed in which projects are being developed. But certainly, I think there's a long, long way to go. In the various territories around the world, there is still so much red tape and development barriers particularly for wind. So I still think the industry has a long, long way to go in that respect.
so I would like to delve into that like geographic component in the conversation a bit later. But I wanted to highlight, I know that you two know each other. You were in a TMGX risk webinar recently. So what were the key highlights from that conversation, particularly on where, an analytics company as Onyx and an insurer as TMGX see the same problem?
On my side, one of the takeaway of this great seminar was the best way to underwrite a risk in a profitable and efficient manner is to be able to quantify it accurately. And this is
Okay.
where we're seeing potential lots of synergies between Ollie's world and my world, between underwriters and technology providers, is how we can support to much better quantify risks.
Yeah, I think that's a pretty good takeaway, to be honest. I think it made it pretty clear from our side that, we need to work more. I mean, it sounds pretty obvious, but we need to work more collaboratively together as two separate industries. AI is really coming to the forefront of insurance at the moment and how we analyze risk. But I still think that's got a long way to go. And so the closer that the two industries can work together to find, better solutions to support the green transition, the better for those that are developing, and great improvements we made to the way in which the speed in which we can deliver the green transition if insurance and AI can work much closer together. So it's about data sharing and it's about an understanding and working closer together, as I say.
Yes, and we're seeing these types of synergies all across the board, not only for wind, but also solar, even new gas. Like we're having more conversations among different stakeholders in the development process. So I'm not surprised at all to see that these types of synergies are creating more value and increasing the IRI of these types of projects. And I love that you mentioned AI because we are going to talk about that a bit later in the show. But let's like take a step back and set the scene because there has been a lot of movement on the policy side, regulatory side, and overall the market dynamics all across the world. So if you had to describe the health of the wind space today, how is it? And are we seeing any major differences among regions, particularly thinking about the US and Europe?
Well, one thing not to forget is that the industry is fundamentally healthy because the
Okay.
demand for electricity, has grown and continues to grow over the years, and the demand for decarbonized electricity continues to grow. So we expect that the global electricity demand, is expected to grow by 4% through 2027, largely driven, as you mentioned, by AI, electrification, and industrial demand. However, I think it's fair to say that Europe and the US follow now a kind of different path. Europe remains primarily driven by climate policy,
Mm-hmm.
energy security and sovereignty, and decarbonization. So, for instance, to give a couple of numbers, Wind Europe estimates that Europe will install approximately 187 gigawatt of new wind capacity between 2025 and 2030, right? So it still falls short of the EU climate targets, but that's a massive growth driven by those trends. In the US, the story with the evolution of the policies lately is more investment driven. And
Mm-hmm.
despite the political uncertainties, electricity demand from data centers, manufacturing reshoring, and industrial electrification continues to be hungry for more renewable investment.
Mm-hmm.
And so we see continued projects in the US driven by those investments in AI. And so that's really a slight difference between the drivers of Europe and US that we're seeing lately.
Yep. And how do you balance that, for example, with your own clients? Like we have these two very different approaches, right? Like on one side, you have the push from the policy side, energy sovereignty, that I actually think that with the Middle East conflict, that has gained even more traction and the role of renewables in this conversation. But in contrast, you also have, or actually, it may not necessarily be a contrast. It's just to complement that with the expected increase in demand, everyone needs power yesterday. So different developers, off takers keep looking at the different options of, okay, what can I develop as soon as possible so I can go ahead in the AI race. So how are you scoring out these conversations with your clients? And Ollie, I'm particularly interested to see how does this influence the approach from the insurance perspective to manage all this risk that comes with new demand, larger turbines, and all the changes that we're seeing in the market.
There is obviously a huge amount of change going on. I mean, you've mentioned certain things geopolitically that have made things come to the forefront once again. I mean, one of the big things for wind, obviously, in terms of how things are changing is cost. The cost of wind versus solar and BESS, or also or co-location, but certainly solar in isolation, is so much greater, obviously. So what we're seeing from our clients really is a diverse portfolios across the technology types, but a big push into solar. From a planning perspective, but particularly from a cost perspective, that is obviously become a very different scenario and a much easier one in many ways.
In the particular case of wind, and it's something that you were both alluding to earlier, that we're seeing turbines becoming larger. So you have more power concentrated in a smaller geographic footprint. And it's not only more power, it's also higher cost in a less area. So at what point does like a bigger turbine become actually riskier? And how is this new risk being managed by developers and the OEMs, but also how is that being processed by the insurance companies?
Yeah, I mean, certainly, we've been writing insurance and reinsurance for renewable energy, particularly wind, for nearly 25 years. Unfortunately, larger turbines doesn't necessarily mean, in our experience, that it's necessarily better technology from a risk perspective.
Okay.
Replacement costs for wind are obviously far greater the larger the machine. Admittedly, the premium pool to pay the claims is larger, but the speed in which the larger turbines have come to market can make the industry, certainly the insurance sector, question, the lengths that have been gone to on the R&D side, to make
Mm.
sure that these machines are and technology is fit for purpose. The vast majority are, of course, they are, and some of the testing is, extremely extensive and very robust. But we still continue to see, so many issues across all technology types, particularly from a breakdown perspective on wind, and so that's still a big issue that the industry has to grapple with. Insurance is about the unforeseen, obviously. So even with all the testing in all the world, and there's only so much the OEMs can do, to be fair, you can obviously never predict the future, and we are here for the unforeseen. So it will always be very challenging in that respect. But the technology growing at such scale so quickly is definitely making it much more difficult from an insurance perspective to price risk. From our perspective, the older turbines, the sort of sub 2 megawatt machines, they're very proven now. We've got almost 20 years of loss data on sub 2 megawatt machines, so we know exactly the ones that work well and the ones that don't work so well. On the newer turbines, we just don't have that loss history or that loss experience, which is ultimately where we understand the exposures that are involved from a breakdown perspective, which allows us to price risk more effectively.
Yeah, and I know that we keep saying this in the research side that correlation does not necessarily mean causality. So even with all the amount of historical data that is available out there, as you mentioned, it's complicated to predict the future. So how is someone going to know exactly what the operation of an asset of any type is going to look like, as we're seeing with climate change, with geopolitical conflict, with I mean, there's so many things to consider that I'm not surprised at all to see all the different factors that are being considered when thinking about risk and trying to quantify that and put a price to that.
Exactly.
You're talking about the increased scale of turbine. And definitely we've seen, from 2 to 3 megawatt type of turbine a decade ago. Now we're going to 6 to 8 onshore and, 15 to 18 offshore. And what we're seeing is it may be not the increased amount of failure, but is the consequence of failure that is dramatically increasing. We see more complex blade damages. We see bearing and drivetrain load associated with larger rotors. So all these increased scale increases the consequence of failure, and also the lost generation. As you have a larger turbine, the expected production of those turbine is higher, and loss of production that the underwriter has also to address is also getting significantly higher.
That's exactly right. I mean, the other issue with the fact that the industry has moved so quickly is the supply chain. These large machines don't have the robust supply chain that the older, more established sub 2 megawatts, to just keep referring to the same models, but they have that mature supply chain that insurers can rely on, because obviously one of the biggest products that our insureds are buying is business interruption, so loss of revenue as a result of a material damage incident that we cover. The lenders on the project insist that product is bought, because they need to be put back into the same position as they were pre-loss from a financial standpoint in the event that they have an insured loss. And the supply chain is still struggling from COVID, to be perfectly honest. It sounds dramatic, but
Wow.
it's still taking time to properly catch up. And on the larger turbines, there is obviously less supply chain, less replacement parts for those larger turbines. So that makes the life of the insurance companies far more difficult, because that downtime is so much greater.
So ultimately, how can we as an industry like balance everything out so we can still get the upside from increased scale, increased speed of development, and having access to these new technologies available without overextending and like trying to manage risk as best as possible?
Well, definitely, this is where I believe technology, gets into play in order to get the upside of scale without, the downside of what we talked about. It's about anticipating, it's about forecasting, it's about then preventing small failures to turn into catastrophic failures. And this
Hmm.
is where technology, with a blend of physics based modeling and AI, allows to have this much better understanding of how to, again, to prevent these catastrophic failure and these supply chain breakdown. And this is
Yeah.
where the digitization of wind turbine, the collection of data, and the processing of those data with the relevant modeling allows to much better anticipate. And this is really something that the underwriter industry can have access to in order to better quantify and estimate future risks.
Information is power. Totally.
Exactly.
Exactly. And then the other big thing, obviously, unfortunately, it's about money and it's about investment
Hmm.
to support the supply chain. That's a crucial part of this, and very difficult to move forward without some significant improvements in that area as well.
Switching gears for a bit, and I want to talk a bit about Alexi. You mentioned a very interesting analogy when we were discussing in our prep call about the smoke detector paradox. So, could you please share this with our audience? It was great.
Well, actually, nobody installed smoke detector because they prevent fires, right? They install them because early detection prevents small problem to become catastrophic losses, right?
Okay. Yeah.
And wind industry is moving exactly in the same direction, right? Now, what's striking is that while some industry have been enforcing those type of instrumentation, data collection, and safeguard measures, wind industry is still in the journey of getting there. And what's striking is that while you have all these mandatory equipments in your residential home in order to have the proper underwriting and the proper insurance, when you're talking about multi-million dollar assets, wind turbine that are far away, hard to reach, and remote, we don't have yet this type of mandate
Oh,
and
wow.
this type of standardization. So that's something that we're getting there, but step by step, I would say.
And that's quite striking. I would assume that any like with any large infrastructure project there would be a more sophisticated approach. So why is the wind industry, so to say, less mature as, let's say, what you mentioned, property insurance, transportation insurance, which we are all familiar with? Why aren't we moving from a prescriptive or reactive approach, more towards a preventative approach?
Sorry, I've lost light in here, so apologies. It's got a bit dark. For the insurance industry, the big thing really is renewables is still relatively new. It's in its relative infancy. We've been involved with the market as part of the green transition for 25 years. We were one of the first to be doing so. But compared to other lines of specialty insurance business, underwritten, around the world, particularly in London, it's still a very new class of business. So whilst 20 years of lost data sounds like a big number, it's not really. The marine insurance, reinsurance market's been around for 300-400 years. They don't have 300 to 400 years of lost data, but they understand risk in the marine sector far better, really, because they have that vast loss data compared to our industry. And you can say that about many other specialist classes of insurance and reinsurance, aviation in particular, marine, upstream energy. These are classes of business in insurance that have been around for so much longer. And as I say, therefore have more loss data to learn from, that we are still in its infancy, or relative infancy, as I say.
So then what changes? Okay, on one side, there is still some data, obviously not as long as a track record compared to other industries. But what is the issue when trying to price off of the historical data that is currently, that is the current information that is available, versus what happens when you're actually seeing the condition of the asset?
Well, certainly where the industry is moving with people like Alexis is obviously having more live data and understanding the condition monitoring, or the condition of the machines at that given time, at any given time, as Alexis can talk more about than I can. But for us, we're obviously renewing or looking at risk on a daily basis on different construction and operational policies as they come to renew, or they're coming to incept. And at the moment, we can only go on the information that's provided by our clients as to the condition of those machines. Obviously, those that provide more information, well, it can work both ways, but those that provide more information, we're usually able to be more commercial, because information is power, as we were saying earlier. But the more we understand the risk, the more we're able to provide competitive solutions. Now, obviously, that can work the other way. The more we know, and actually these machines are not in a good condition, then it can obviously work the other way. But information is absolutely critical, and communication between the various stakeholders in the project is essential for us to understand the risk and price it effectively.
And then, Alexi, is information currently available enough to support the decision-making process for the underwriting industry?
Well, information is getting more and more available. We have now solutions that are either installed at factory or that can be retrofitted in terms of data acquisition with a whole set of sensors that you can install in the wind turbine. It's really a matter now of combining those different data streams. You have operational data. Without getting too technical, you have operational data coming from SCADA, and you have data coming from the condition of the turbine, whether it's vibration data, temperature data. Really, what's critical is to have access to those different set of data in order to integrate them and have a unified model of your turbine, which allows applying physics rules and AI to better forecast the behavior of the turbine. So it's really, now the technology is here to have access to the data. It's about integrating those data into a single model in order to provide the proper health representation and performance representation of the turbine.
So it's not only improving the quality of the data available itself, it's also improving the way that we're processing the data and using it to make more informed decisions, and ultimately inform how to approach maintenance, how to approach the most optimal operation of an asset then.
Exactly.
There has been, and you can confirm actually, my understanding is that blades is where a lot of the most expensive and most dangerous failures happen in a wind project. So Why are blades such a hard problem, and why there has been not enough monitoring done so far?
Well, blade combines several difficult characteristics. First, they are the largest composite structure in the turbine. Uh, they're systematically exposed to rain, lightning, UV, hail, fatigue loading. So they're extremely exposed to the outside environment. They're difficult and expensive to inspect, and there is also a high level of variability because composites age differently from steel component. So all this variability and exposure to the outside environment makes it hard to really understand, harder to understand than drivetrain monitoring that has been, here for decades, and it is much better understood.
Isn't drone flying enough?
Well, drone is great, and drone is required to understand the evolution of the outside structure of the blade. It doesn't tell you what's happening inside the blade.
Okay.
Number one. Number two, it's not real time. It's
Yep.
every quarter, every semester. So depending on how you schedule your campaign, and you may have a crack inside the blade that progress way faster than the time between two drone inspections, and then it's too late.
I completely agree with Alexi from a lightning perspective. From an insurance perspective, the biggest single issue on wind, if you take out the more traditional natural catastrophe perils like earthquake, named windstorm, and hail that we cover, lightning is by far the biggest issue that we've had over the last 20 years. The severity is increasing, the frequency is increasing. Admittedly, in simple terms, there's far more of them around the world now, so there's more conductors in the air for electricity, for lightning. But it's the single largest peril from a frequency and severity standpoint, as I say, and it is so expensive. These blades now, the large onshore and offshore machines, they are so expensive. They're being built. The developers or manufacturers are trying to understandably build them cheaper and faster and lighter, obviously. And there's all sorts of issues in our experience that can happen with, different materials. But yeah, lightning by far and away the largest amount of claims that we paid over the last 20 years.
So obviously we cannot control lightning or any type of environmental condition, but there are other solutions in place that can either help prevent some of the damage or minimize any damage done. So could you tell us more of what you have seen in terms of solutions to these problems?
We have seen solutions. Yep, some of them work, some of them don't. In simple terms, and I'm certainly not going to name and shame, but yeah, there are some very, very good viable solutions out there, and there are some that simply aren't fit for purpose, and that has been a major, major issue for the industry, without a doubt.
On my side, being the CEO of Onyx, we have a good history and understanding of the different solutions that are available on the market. We've been partnering with drone inspection companies, but what's really exciting is that in the past years we've launched on the market vibration-based real-time monitoring solution for blades, and installing sensors inside the blade that allow to identify evolution of the structure, cracks. A crack that is 30 centimeter long would cost you $30,000 to fix, compared to a blade snapping, which costs you between, well, let's say $300 to $1 million.
And the rest.
And the rest, right? And it's not
Yeah.
counting loss of production. It's not counting all the PR, especially when you're on shore. We have solutions that have proven extremely efficient and that have been deployed to do this real-time monitoring of the evolution of the structure inside blades.
So effectively, practically a 10x plus savings from shifting from a reactive to a more predictive approach, and leveraging the data that is available to understand first and see what is wrong before it becomes catastrophic.
Correct.
Exactly.
Olly, I think from your perspective, we were talking earlier about using new technology, and how sometimes it might work, how sometimes it doesn't. So, are you seeing that this type of more sophisticated intelligence, particularly on the blade side, is helping to reduce catastrophic failures, or in general, just having smaller, shorter business interruption?
Being brutally honest, not yet. It is happening, and some of the signs of what this information technology, for example, can do is very, very promising. But as you can imagine, as an insurance company, we're slightly reserved on these things, and we really want to see it proven, time tested in the field for a significant amount of time. Define significant, but for a lengthy amount of time where we can truly believe and understand that what it says it's doing, and is able to do and to achieve, and that is exactly what it's doing and what it's able to achieve. And I'm confident that will happen. But again, it does need time, and it needs people like us in the insurance industry and people like Alexi to work much closer together to get a better understanding of what each other requires.
Thinking about other issues that are happening in the industry, one that has been mentioned more and more is the aging fleet. So we're seeing more capacity being retired, and the decision on what to do next is becoming more and more complex. So, Alexi, can you tell us how your clients are approaching this decision among repowering, extending the life, or just retiring the asset? And what is the role that data is playing in this conversation?
So this is actually, for tech companies like us, this is really an exciting moment, because we're at almost the end of the first cycle. We see turbine now that are getting 15, 20 years old, the first set of large turbines. And so we are really at the time where our customers are wondering whether they would extend life, whether they would repower, partially repower. So we have a lot of discussion with our customers. And this is where technology and data plays a critical role, because more and more the decision is based on the condition of the turbine more than just its age, right? So if you've been capable to understand the condition of the turbine, what the turbine experienced in its lifetime, the stress that it had to go through, and the actual condition of the turbine, then you're capable to make much better decisions, and much more financially relevant decision between extending the lifetime or repowering. And this is where technology allows you to get access to the data on the condition of the turbine and make those decisions.
Only from your perspective, when underwriting an older asset, like how does it work actually? Is the conversation different from a new asset perspective versus repowering versus life extension?
Yeah, I mean, we obviously look at our loss data, and we understand when certain turbines tend to start to fail. And again, the introduction of AI will improve that view immensely over time. But yeah, we've got an understanding of older machines, particularly if they're not looked after correctly and not maintained correctly, can have significant catastrophic failures over certain periods of time. In terms of the repowering question, we're seeing it more and more. Not surprisingly, the industry, particularly in certain parts of the world, those project sites are getting to that age now where the developers are having to make pretty crucial decisions as to what they look to do for the assets or with the assets over a longer term. More often than not, they are looking to repower. Quite understandably, with the leases on land, for example, that tend to outstrip the lifeline or the life expectancy of the asset. Why wouldn't they look to repower? From an underwriting perspective, it's the actual physical piece, the construction exposure piece. It's not drastically different to what we do as we write and insure construction policies and construction projects day in, day out. We need to understand the technology that's being being introduced, but in all likelihood, we will have seen that technology in other parts of the world, and so it is relatively straightforward. But it's certainly not less of a risk than we see on day-to-day new construction projects.
We were mentioning earlier on the operating asset side, the issue about not having enough data to make more sophisticated decisions. What information is there available to evaluate the condition of a current asset and evaluating its remaining lifetime?
We see that repowering versus life extension has to be assessed along a couple of criteria that require access to specific data. For instance, life extension makes sense when the structural condition of the turbine remains good, right? So if you have access to foundation or tower monitoring, which is a technology that is available and that we provide, then it allows you to have a much better understanding of the structural condition of the turbine. The site continues to produce attractive energy yield, and that's also having access to the production data. And these are the type of criteria that would be in favor of life extension versus repowering. However, repowering is attractive when modern turbine dramatically improve production. And as Olly was saying, you have also to take into account all the site and permit type of criteria. But definitely having access to data to understand the condition of the turbine, the evolution of its structural condition allows you to make better informed decision.
So we know that like the role that data plays in informing decisions as we have been discussing throughout the episode. But we also know that data access has been a battleground. So on one side we have the OEMs that have all the operational data, but they are not necessarily sharing that information with other stakeholders, including asset owners and perhaps maybe also even underwriting companies or third-party technology providers. So how is this a barrier? And are we seeing any changes that are showing this condition improving? And is there any policy to highlight that is helping overcome these issues?
OEM data access has been historically one of the industry's biggest challenge, right? And for owners and operators to have access to OEM data, being able to challenge the data provided by OEM and have a healthy discussion on performance, condition, availability. Historically, that has been really a challenge of this industry. We're seeing two things that are allowing to address that. One thing is technology. Now, technology allows to have access to a whole set of data, even when OEMs retain data. We have the possibility to retrofit, to install instrumentation and digitalization of existing turbine, and to provide to the owner and operator a whole set of information that allows to have this healthy discussion with the OEM. Right? So technology allows to do that. And then evolution of regulations, the EU Data Act that mandates availability of data is also really changing the landscape and unlocking this bottleneck in the industry.
I think it becomes even more difficult when there's a serial issue. From the OEM's perspective, which on occasion they do have, getting information out of them at that stage to support and understand what's gone wrong, understandably from the OEM's perspective, can be very, very challenging.
When you say serial, do you mean that like there has been an issue identified with, I don't know, a certain turbine model?
Exactly. Exactly. That's exactly, or a particular component within the a particular model. Exactly right.
Alexi, you have been mentioning the technology perspective, and I promised earlier in the episode that we were going to touch on AI. So, does AI genuinely add value here, or is it more like, oh, look at this fridge that now has AI implemented? So, what is the value added from AI in this case?
Well, really, sensors tell you what's happening, right? And with the amount of sensors that we can install in turbine while remaining completely cost effective, you have a huge amount of data that now you can extract from the turbine, right? AI allows you, helps you to understand why it's happening and predict what's going to happen next. So allows you to process this large amount of data and go beyond the monitoring into the prediction and into the recommendation. Now, what we believe in Onyx is that AI on its own, if it's just about building statistical models, right, would may not take into account the some of the reality that are explained by physics-based model, and it's combining the physics-based model and the AI capacity to process data that you're capable to have a much more accurate understanding of the evolution of the condition of the turbine.
So, to wrap this up, could each of you tell what is your biggest recommendation for anyone that is currently active in the wind space, and any practical changes that they could do to de-risk their projects and improve risk management overall?
From my perspective, and we've mentioned it a few times, it is about, again, collaboration and getting all stakeholders together and understanding, what's required really for the viability of the project. It's about that investment in supply chain. That's a major part of the de-risk process. And it's also about the equipment itself, about improved testing and improved understanding around the reliability through testing of the equipment that we are looking to ensure to help with the bankability of the project and to help with ultimately the green transition.
And from a tech point of view, for me, three priorities stand out. The first one is to establish a unified data strategy. As I mentioned, integrating SCADA data, condition monitoring, maintenance records allows to build a unified model. And this also allows to bridge the gap, I would say, between the world of maintenance, that is condition based, and the world of performance. More and more, we will tackle condition based performance management. Managing your asset at the optimum of its capacity and yield based on this condition. And for that, you need to bridge these two worlds of maintenance and operations. And having a unified data strategy will allow to do that. That's number one. Number two, treat AI as a decision support tool, not as an end by itself, right? And this is why we believe that physics-informed AI is critical. It's not just AI for itself, and that's required to avoid AI hallucination and to keep human decision at the center of the way we manage this industry. And then last but not least, and that's almost a wrap up, is really move towards a risk-based maintenance. It's how do you move from monitoring to prevention by having the right technology and the right access to data. Predictive maintenance programs can reduce maintenance costs by 20 to 30% and unplanned downtime by 30 to 50%. So we talked at the beginning about how the industry is moving step by step, but doesn't have the centuries of history. And we need to fast forward that because now we have the technology to do that, and we need to get there as fast as we can.
not only the technology, but also the demand. So the biggest component right now, and we as an industry need to leverage that. Well, Alexi, Olly, this has been amazing. Thank you so much for joining me today.
Thank you.
Thank you very much. Thank you very much.
Cheers.
And that's it for today's episode of Interchange Recharged. Again, thank you, Alexi and Olly, for joining me today and having such a candid conversation on what this industry needs to grow up and where it already has. If you want to dive any deeper on all the information that we have on wind, you will find our latest research at windmac.com. And if you like the podcast, don't forget to subscribe at anywhere you get your podcasts and on YouTube. So this was Interchange Recharge. Thank you so much for listening, and I'll see you in 2 weeks. Nos vemos.